So in this video, you're going to learn about the four motions of Earth. We're going to start with our essential standards. So objective 1.11, explain the Earth's motion through space, including precession, nutation, the barycenter, and its path about the galaxy. We'll talk about barycenter in a separate video. In objective 1.12, you're going to explain the Earth's rotation and revolution about the sun, how it affects the shape and the Earth's relationship to the seasons and the tides. So there are two I can statements that you need to pay attention to, and that's I can describe and demonstrate the four motions of the Earth and how it affects the Earth's shape. And then the second one is I can explain what causes seasons. So make sure at the end of the video you come back to this slide. I'll pull it back up for you and make sure we can mark off both of these boxes. So we're going to start with knowing what an axis is, and it's an imaginary line about which a body spins or rotates. So then we have our first motion of the Earth, and its precession. It's a slow movement that causes a change in the direction of the Earth's axis. So if you look here, I tried to draw a picture to try to describe the process to you. This is supposed to be my top. I don't know how many of you have played with a drill before, but this is a top, and the actual spin up top, or the movement up top, I should say, is the precession itself. So if I took the top and I attempted to spin it, that is the motion itself, is the precession. So then our second one is a nutation, and it's the wobbling around the processional access. So if you look here, I tried to draw a separate picture, and if you see this vibrational force that's kind of going around in the circle, the vibrational force, that's what a nutation actually is. So you have the precession going around, and the actual vibrating force that's going around through the processional is the nutation. So then we have our third motion of Earth, which is rotation. And a rotation equals 1 day, or it means spinning. So the rotation is the spinning of a body on its axis. It takes the Earth 1 day to complete one rotation. This is what actually creates day and night of the Earth. So the rotations are what creates the day and the night. And remember, one rotation equals, to be precise, 23 hours, 56 minutes, and 4 seconds. So it's actually our clocks that allow us to make it a 24-hour time period. It's really this exact time here. And then the fourth motion of the Earth is a revolution. Revolution equals 1 year, or it means orbit. So it's the orbiting of an object around another. It takes the Earth 1 year to complete one orbit around the sun. And the revolution is equivalent to 365.25 days. So I have a fun fact here for you, and it's about a leap year. So it takes the Earth, like we said, 365.25 days to revolve around the sun. So the Earth gets a day behind schedule each year. So every 4 years, what happens is the Earth gets a whole day behind schedule. So in order to calculate a leap year, what you're going to do is take the year in question, and you're going to divide that by 4. And if your answer is a whole number without a fraction, then you know that you have a leap year. And if it does have a fraction, it's not a leap year. So at the bottom, I have the year 2012 divided by 4, and I get 503. Notice that there is no remaining decimal or fraction here. And this is when the last leap year occurred. And I have this year, which is 2014, and I divide it by 4, and I get 503.5. And this 0.5 allows me to know it'll take another 2 years for us to have a leap year. So I did 2016 divided by 4, and I get 504, no fraction. So we'll have our next leap year in the year of 2016. So then we have, what are the reasons for the seasons? So it's actually the 23.5 degree angle tilt of the Earth on its axis, not how close or how far away the sun is, the Earth is from the sun. It's strictly the 23.5 degree angle tilt of the Earth. So when the tilt of the Earth is toward the sun, that's what's going to cause summer. And then when the tilt is away from the sun, that's what's going to cause winter. So March 21st approximately is when spring occurs or begins. June 21st is approximately when summer begins. September 21st is approximately when fall begins. And December 21st is approximately when winter begins. So a good point to remember always is that the northern and southern hemispheres have opposite seasons. We live on the northern hemisphere. So when it's spring in the northern hemisphere, it's actually going to be fall in the southern hemisphere. When it's summer in the northern hemisphere, it's winter in the southern hemisphere. When it's going to be fall in the northern hemisphere, it's actually spring in the southern hemisphere. And when it's winter in the northern hemisphere, it's actually summer in the southern hemisphere. So these are good things to remember as you get to the point in your life when you get to travel around the world. You need to remember the temperature and the season that we have is not necessarily the case in other places around the world. So we're going to go back to that original board. So you should now be able to describe and demonstrate the four motions of the earth and how it affects the shape. So remember, the first one is precession. And that's like if I take the top and I spin the top, that motion that's going around is a precession. And then the second one is nutation. Nutation is once the precession is occurring, it's a vibrating force that's also occurring at the same time when the earth is on its axis. The third one is a rotation. And remember, rotation also means spinning. So just like if I were to take a basketball and I would put it on my finger and make it spin, that's the same thing the earth does in a day. And then I have a revolution. And this means orbiting, and that's the amount of time that it takes the earth to actually complete an orbit around the sun. So we should be able to mark that one off. And then remember, it's actually the 23.5 degree angle that causes seasons, not the proximity of the earth to the sun. So good luck.